calculus and we did integration of exponential functions. Next subtype is integration of sine, cosine, and secant square functions. For sine and cos, we had this mnemonic. In case of differentiation, we had sin x minus sin x, cos x minus cos x. The differentiation of sine was cos, differentiation of cos was minus sine. This was d over dx. And this is the reverse in case of integration. So integration of cos is sin x, integration of cos is sine, and sine is minus cos. Integration of sine is minus cos. And if we would have anything inside the bracket, for example, in case of differentiation, it was, let's say, sine 2x plus 3. So dy by dx was differentiation of sine was cos, and then whatever is inside the angle multiplied with differentiation of that. Now, what is the case? If we are having sine 2x plus 3, first we integrate it, and integration of sine is minus cos. And whatever is inside, we differentiate that and divide with it. Minus 1 by 2 cos of 2x plus 3. The reverse process. So from cos to sine, sine to minus cos, and secant square. Integration of secant square is 10x plus c. We had to write plus c there as well. So we'll be using these identities and solving few questions. And then another subtype. So first example, sine 2x integrating sine 2x dx. So when we integrate sine, I'm just using my mnemonic. This was sine, cos, minus cos, and moving in anti-clockwise direction, integrating sine, it becomes minus cos 2x, and into 1 by 2 plus c. And definitely we'll just rearrange and simplify. That is minus cos 2x by 2 plus c. Next is integrating cos 5x dx. Integration of cos is sine. So sine 5x, and differentiating the angle and dividing with it. Now we have secant square. Integration of secant square was tan. 3 secant square x by 2 dx integrating. So this 3 just comes down along as constant. Secant square becomes tan x by 2, and differentiation of angle is 1 by 2, and we divide with the differentiation plus c. Simplifying that makes it 6 tan x by 2 plus c. Okay. Now he's just increasing the terms in the question, that integrate 3 cos 2x plus 5 sine 3x dx. So integration of cos is sine. 3 sine 2x and divide with the differentiation of angle plus integration of sine is minus cos. Minus 5 cos 3x and divide with the differentiation of angle plus c. So that's integrated. Try this b part.
B part.
Yeah, work solution, B part at the top.
Oh, so just the second part is, I guess, just applying the formula, and then just it's just like the formula with the numbers plugged into it. Okay, and I'll see if I match the final answer.
Yeah.
Yeah.
Mm,
So split it, and then afterwards integrate it separately, and then connect them back together.
yes. Now this one would be quick, and then we'll move on to next subtopic. So sine integration is minus cos. So that's minus cos 4x over 4 plus c. This is cos integration is sine. So sine 2x over 2 plus c. Right? Try
Yeah.
E part.
E part.
Yep.
Oh, that one. Okay. So it's cos 2x. That's sine, right? So it'd
Yep.
be 2 sine 2x.
Yes. And then we divide with the differentiation of angle. E part is 2 cos 2x dx integral. And yes, cos becomes sine, and we divide with the differentiation of angle. And then there is simplification. So we're left with sine 2x plus c. Try F part.
So negative 6 sine 3x over.
Negative 6 cos 3x
Yeah.
over
Yeah. So negative 6 cos 3x over 3, right?
plus c.
Plus c.
And simplification. G part. So the integration of secant square was tan. 2 secant square 3x dx. Integration of secant square was tan x, and in differentiation of 3x is 3 plus c. H part. So we have 3 cos 2x plus 1 dx
A sine 2x plus 1, and then
three
it would be over
and over
2.
2 plus c. Okay. I'm going for C part. Question 2c. Integral 3 cos 2x minus pi sine 5x over 2 dx. Now cos integrated would become sine, and no need of this sine. So that's 3 sine 2x over 2 minus pi. Sine becomes minus cos, so minus minus will be positive. Cos 5x over 2, and differentiation of angle is 5 by 2 plus c, and simplification. 3 sine 2x over 2, this 5 by 2 will become 2 pi cos 5 by 2x over 5. This is the angle part, and that is the denominator. Try E part. 15.5 to E.
So we would split the integral, and then it would be the integration of e2x dx minus 5, and then the integration of sine 2x dx. And integrating e2x was, the formula was eax dx equals 1 over a eax, right?
Yeah.
So
Right.
that would be 1 half e2x, and then integrating sine 2x, so that's negative 1 over 2 cos 2x. So then afterwards we can multiply that with negative 5, and then that would get us 5 over 2 cos 2x. And then we just combine them.
That's right. And plus C.
Yep. So 1
Okay.
half 2x plus 5 over 2 cos 2x plus c. Yeah.
A curve is such that dy by dx is given. So question 3, dy by dx is given, which is cos x minus sin x. So given that the curve passes through this point, find the equation of the curve. So we'll integrate it. Then equation of curve is integrating cos x minus sin x dx. So y is equals to cos becomes sin x minus sin becomes minus cos x plus c. And we have that point which is x is pi by 2 and y is 3. Y 3 sine pi by 2 minus cos pi by 2 plus c. Now there are two things which we can do, is either if there's calculator, definitely you can use that, or else you would remember these triangles. This was 90, 30, 60 from trigonometry, 1, 2, and square root 3. And then we had another triangle, which was 1, 1, square root 2, 90, 45 degrees, and 45 degrees. Similarly, we can redraw them in case of radians, or let's just use the same for radians. 90 is pi by 2. And I just got to know that it's 90. So wherever we like need this, this is pi by 3, that's pi by 6. This is pi by 4, pi by 2, pi by 4. And the other thing was, if I'm talking about sine, I know that this is pi by 2. And sine pi by 2 is 1 at its max. So this is 1 minus, when we're talking about cos, this is 1, 2, 3, 4 equal intervals. That's pi by 2, and cos pi by 2 is 0. Plus c, that's 3, 3 minus 1 equals c, c is equals to 2. The final answer is equation is y is equals to, I'm rewriting this. Y is equals to sine x minus cos x plus 2. So when we integrate this, we get sine x minus cos x plus 2 according to the given point. And let me just check that as well. This was question 3, 15.5. 15.5 question 3 is yes. That's correct. Try question number 4.
I'm getting x minus 2 sine 2x plus 3 minus pi over 4.
Correct. That is the exact answer. So you get the theme. We just integrate it, substitute the given value, find the value of c, and rewrite the equation. One more, and then we'll move on to subtopic. Now look at question 6. It would require integrating it 2 times because double derivative is given. Says d
So you
square.
integrate it once, and you just do the same things again.
Yes. Cos of 3x plus 2 sine x. So a curve is such that double derivative is this, given that dy by dx is equals to minus 2 and x is equals to 0. And then the curve passes through the point this, find the equation of the curve. So we go step by step. First integral will give us dy by dx. So dy by dx is this first integral. Cos changes to sine. This is 45 sine 3x over 3, and this changes to minus cos minus 2 cos x plus c. Before I substitute, I would simplify 15 sine 3x minus 2 cos x plus c.
Wait,
Now,
so it'd just be minus 2 x, and it wouldn't be over. Oh, because it doesn't have anything on the angle, right? So it'd just
yeah,
be. Okay.
no. Yeah, on the right hand side, that was only x, so it is supposed to be 1.
Yeah, but we don't have to write it. Okay.
Yeah,
I thought it was something there. Never mind. Okay.
no issues if you write it or leave it. Okay. Then we have this first set that dy by dx is minus 2 at the time when x is 0. So this is 15 sine of 0 minus 2 cos of 0 plus c. So minus 2 sine 0 is 0 and cos 0 is 1. So that's minus 2 plus c goes on the other side and c comes out to be 0. So if c is 0, we can rewrite that dy by dx is simplified to 15 sine 3x minus 3 minus 2 minus 2 cos x. And now we integrate it again. Y is equals to 15. Now sign changes to minus cos dx over 3 and minus cos changes to minus sine minus 2 sin x plus c. Simplification, that's minus 5 cos 3x minus 2 sin x plus c. And this time it is pi and minus 1. That's minus 1 minus 5 cos, that would be 3 pi minus 2 sine pi plus c. Now again, we can see either I use the curve or I use the calculator. See, that's 0, pi by 2, that's pi, 3 by 2 pi, and 2 pi. So definitely this is going to be 2 pi and then another round, that's pi. So I can see it from here. This was sine pi is 0 and this part becomes 0, that's c. On the other hand, if we
We had to do it twice. We had to do a full rotation
for
and then
cos,
another.
yeah, because it would end at 2 pi. So I'll just pick up from this point that this is pi, that's 2 pi, another half, another half. See, that's 0, that's pi, that's 2 pi, that's 3 pi, another half. That takes me to minus 1. Either you change your calculator in degree in radian mode and check cos 3 pi.
Cos 3 pi?
Cos 3 pi in calculator or from graph, we get minus 1. So minus 5 into minus 1. Now this simplifies to minus 1 is equals to 5 plus c. 5 goes on the other side, makes it negative 6. And y is equals to minus 5 cos 3x minus 2 sin x minus 6. And I just hope there's no elementary mistake. Let's check this is question 6. Minus 5 cos 3x minus 2x and minus 6. That's correct. And similarly, this is just the type that it is trigonometric, how to integrate it. We may have questions that find the equation of the tangent. So we'll just differentiate if it is tangent and substitute the given value, or if the tangent is given, we may integrate to find the equation of the curve and so on, whatever the statement is. Next subtopic, before we move on to this,